Hey everyone, welcome back to the channel. Before we dive into today's repair guide, make sure to hit that subscribe button, give this video a thumbs up, and ring the notification bell so you never miss another step-by-step automotive tutorial. Today, we're tackling a super common issue that sends a lot of drivers straight into a panic: that bright yellow or orange ABS light suddenly glowing on your dashboard. Often, it pops up right alongside your traction control or stability control light. While brake issues can be intimidating, in the majority of cases, an ABS light isn't a catastrophic brake failure, it's simply a faulty wheel speed sensor. In this video, I'm going to walk you through how to properly diagnose a failing wheel speed sensor step by step, using basic tools you likely already have in your garage. To understand how to diagnose the problem, it helps to know what a wheel speed sensor actually does. Your car has a sensor mounted at each wheel hub or brake assembly. These sensors constantly monitor how fast each individual wheel is spinning and feed that real-time data back to your anti-lock braking system module. If you slam on the brakes on a slick road, the ABS module uses this information to prevent the wheels from locking up, allowing you to maintain steering control. When one of these sensors fails, gets dirty, or loses signal, the ABS computer shuts down the anti-lock feature as a safety precaution and turns on your warning light. You'll still have normal mechanical braking power, but your anti-lock features and traction control will be disabled. The absolute best place to start your diagnosis is with an OBD2 scanner that supports ABS Diagnostics. Keep in mind that a standard entry-level code reader usually only reads engine check lights, not ABS codes. You'll need a scanner capable of reading chassis codes, which usually start with the letter C. Plug your scanner into the port under the dashboard, turn your key to the ignition position, and run an ABS code scan. The scanner should give you a specific code, such as C0035 or C0040, which points directly to the problem area, for example, front left wheel speed sensor circuit malfunction. Knowing exactly which wheel is causing the issue saves you from guessing and checking all four corners of the car. Once you know which wheel is throwing the code, it's time for a physical inspection. Jack up the car safely using properly rated jack stands and remove the wheel. Locate the sensor mounted behind the rotor on the steering knuckle or wheel bearing assembly. Follow the wire back up into the wheel well to find the electrical harness connector. Carefully inspect the entire length of the wire for frayed insulation, severe pinches, or damage caused by road debris or rubbing against suspension components. Disconnect the sensor plug and look inside the pins for rust, corrosion, or bent terminals. While you're there, look closely at the tone ring, also known as the reluctor ring, or the magnetic strip on the wheel bearing. A cracked, clogged, or heavily rusted tone ring can prevent a perfectly good sensor from reading properly. Sometimes, simply cleaning thick brake dust, dirt, or metal shavings off the sensor tip with a brake cleaner spray and a soft rag can instantly solve your issue. If the wiring and sensor look visually intact, you'll want to test the sensor electronically using a digital multimeter. Wheel speed sensors come in two main types: passive and active. Passive sensors are two-wire sensors that generate their own small AC voltage as the wheel turns. Active sensors, which are more common on modern vehicles, use 3 wires or 2 powered wires and rely on an internal Hall effect chip. For a passive sensor, set your multimeter to resistance or ohms mode and place your probes on the 2 pins inside the sensor connector. A healthy passive sensor typically reads between 800 and 1400 ohms, though you should check your specific vehicle's repair manual. If you get an open circuit, reading infinite resistance, or 0 ohms, the internal coil is broken, and the sensor needs to be replaced. You can also switch your multimeter to AC voltage, spin the wheel hub by hand, and watch for a small AC voltage signal, usually around 0.5 to 2 volts depending on how fast you turn it. If you have an active sensor, testing resistance directly with a multimeter isn't always reliable and can sometimes damage delicate internal electronics. Instead, set your multimeter to DC voltage and check the harness side to verify that the vehicle is supplying power, usually around 5 to 12 volts, to the sensor when the ignition is turned on. If power is reaching the sensor but the ABS module isn't getting a signal back, you can use your OBD2 scanner's live data feature if your tool supports it. Set the scanner to stream live wheel speed data, then manually spin the wheel or take a short, cautious test drive in a safe parking lot. If three wheels display speed in miles or kilometers per hour and the problem wheel stays flat at 0, you have confirmed a dead sensor.